Yeah. Getting new ones every year. Are you getting one every year?
Okay, I feel like if we don't start now, we're never gonna want to start. But I promise what we're doing today is so easy. Okay, so we're gonna learn how to find horizontal asymptotes today. This is what happens at the end of your graph as x is going either to infinity or to negative infinity. Okay, so last time we learned how to find vertical asymptotes. You remember that's where you factor and it's left over on the bottom. And then we learned how to find holes where you factor and they cross out. Horizontal asymptotes are way easier to find. Here's what you're going to do. There are 3 rules that you have to follow. And they all have very silly acronym names, but just go with it. The first one is BOBO. Okay, BOBO is bigger on bottom. Okay, so bigger on bottom, and if your expression has a bigger power on the bottom, then your ends are gonna approach 0. So bigger on bottom, 0. The other option is it could be bigger on the bottom or bigger on the top. So bottom is bigger on top. And then the N means none, or that you don't have a horizontal asymptote. So if the bottom is bigger, your asymptote is 0. If the top is bigger, you don't have one. Okay, so just to give you 2 little quick examples of that. Let's say that you were graphing 3x cubed plus 5x over 10x to the 4 plus 7x. Okay, the top power, you're looking for like the biggest power on the top would be an x3. But on the bottom, the biggest power is an x4. Then you would just ask yourself which of those is bigger. In that case, what's bigger, x3 or x4? 4, then you would say this is bigger on the bottom, and your horizontal asymptote would be 0. Now, here's what that means. Your graph is going to do whatever in the middle, but at the ends of the graph, it's going to flatten out to 0. So we're going to draw a little sketch of that. Okay, this is not this actual graph. This is just a graph that does that. Okay, it could be whatever you want in the middle. Let's say it does that. Okay, but then at the ends of the graph, it's going to taper off flat towards 0. And then it's going to taper off flat towards 0. So this doesn't tell you anything about the middle of the graph. Horizontal asymptotes are only at the infinities. So this will tell you what it does. Now, if your graph isn't approaching 0, that just means it's going up or down. That's what no asymptotes would look like. So I'm going to take this exact same equation, but I'm going to flip it so that now the x4 is on top and the x3 is on bottom. It'd be 10x4 over 3x3. And so if that were your example, you'd look at the top, look at the bottom, be like, okay, which of these powers is bigger? My biggest power on top is an x4. Biggest power on bottom is an x3. Then you would say, okay, that's a bottom. Bigger on top, no asymptote. And so then we'll just sketch a quick picture of what that could look like. Okay, remember the middle of the graph can do whatever it wants. This does not tell you anything about the middle. So maybe it does something crazy, but your ends are not tapering off. They're just maybe going up or going down, but they're not flattening out towards anything specific. Okay, so there's no flattening out towards 0 or any other number. They're just going up forever or down forever. Okay. The last option, it could be bigger on bottom, it could be bigger on top, but the other option is there could be a tie, that both of their powers are the same. Okay, we're gonna call that bed C. Okay, bed C stands for both equal powers. You're gonna divide the coefficients in the front. Okay, divide coefficients. So bed C is both equal, divide coefficient. Okay. And then for our example, we'll make the top and the bottom both x4s so that it's a tie. So for your example, I'm gonna give you 10x4 plus 7x, and then a 3x4 plus 5x. Okay. So then you would look at that and you would say, okay, all the way across the top, the biggest power that I see is an x4. All the way across the bottom, the biggest power that I see is an x4. Then that's a tie. Then you're gonna take those numbers in the front that are called coefficients and you're gonna divide them. So you would say, okay, then my ends are gonna approach y equals 10 divided by 3. And then if you divided 10 by 3, what would that be like pretty close to? We can't divide 10 by 3, but what's 9 divided by 3? 3. So 10 divided by 3 would be a little bit bigger than 3. So let's just do a quick sketch of what that graph would look like. Give me a grid. Count to 3. 1, 2, 3. And then remember, it's not exactly 3. It'd be like 3.3. So I'm going to draw in my horizontal line right here. Okay, remember, I have no idea what happens in the middle of the graph. The only thing the horizontal asymptote tells you is that at the ends of the graph, it's going to be flattening out towards that line. So I'm going to do the same kind of crazy shape in the middle. But then on the ends, it's going to start approaching that asymptote. Okay, and then on the other side, same thing, I'm going to approach that asymptote. So horizontal asymptotes only tell you what the ends of the graph are doing, nothing in the middle. Okay? But we already learned about all the crap in the middle when we were doing vertical asymptotes, poles, even and odd, balances and x-intercepts. We'll put all that together next time. Okay, so today, look at number 1. What is the highest power that you see on top? Power meaning exponent. 2. It's an x squared. What about the highest power on the bottom? x3. So then I would say, which of those is bigger? Is it a bigger power on top for bottom? Bigger power on bottom for Bobo? Or is it a tie? That would be a Bobo then, right, Bobo? And remember, that stands for bigger on bottom. The answer is 0. So y equals 0. And if you graphed it, your ends would be curving off towards the x-axis. Go on to number 2, please. Is it a Bobo, bigger on bottom, bigger on top, or bed C?
Bed C.
That is a bed C, because what are both of the powers? Just regular x's, or x to the 1, technically. So if it's a bed C, what does that stand for? Both equal, do what? So I'm going to divide 15 by 5. What is 15 divided by 5? Then your answer is y equals 3. So then the ends of your graph would be curving off towards a flat line at a height of 3. Okay, one more like that. Take a look at number 3. What's the highest power on top? 5. What about on bottom? 2. Then which one's bigger? X5 or X2? 5 is on top, that makes it a bottom. Okay, and remember what it stands for. Bigger on top, none. So you would put no horizontal asymptote. Okay, Now, sometimes people will say, well, wait, if it's 100, how is that not bigger? Remember, you're not looking at the coefficients, you're looking at the powers. Okay, go ahead and turn the page, please. Couple more examples left. Take a look at number 4. Bobo, Botan, or Betsy. Okay, this one was kind of a trick. It is a Betsy, because remember, you're not picking the front thing, you're picking the biggest thing on top. What's the biggest power on top? Negative 4x3. On bottom, it's a 2x3. That does make it a Betsy. What does Betsy stand for? Both equal, do what? Divide coefficient. So I'm going to do y equals. My coefficients are negative 4 divided by 2. What is negative 4 divided by 2? Negative 2. Next one, look at it closely. Bobo, Botan, or Betsy? It is a Betsy, because what's the tie power? X to the 2. So I have a 10x2 and a 15x2. Then y equals 10 divided by 15. Now, if you type that in as your answer on your practice, which is only 8 questions, it'll count it wrong because why? Yeah, it's not simplified. So what can both of those divide by? So I'm going to divide by 5 on top, divide by 5 on bottom. So 10 divided by 5 is a 2, 15 divided by 5 is a 3. Okay, if you want me to show you how to reduce that in the calculator, I can, but hopefully we can do it without. Number 6, Bobo, Botan, or Betsy? It is a Bobo because it's a regular x versus an x squared. X squared wins and it's on the bottom. So remember what Bobo stands for? Bigger on bottom, ends go to 0. What's number 7? Bobo, Botan, Betsy. It is a Botan, and Botan means none, or no horizontal asymptote. Okay, 4 more left. Take a look at number 8. If you see parentheses, you need to be a little bit careful. Parentheses means your equation is coming to you in factored form. And the only problem with that is that you need to multiply all of the x's to see how big the top and the bottom really are. So for example, if I'm doing number 8, my coefficient isn't a 3x, it's a 2 times 3x, which is what? Okay, 6x. And then I'm going to put dot, dot, dot. Okay, the reason why is because you don't need to know the whole thing. You just need to know what that biggest first term would have been. Okay, on the bottom, I have a 3 times a 5x. 3 times 5 is what? 15x, dot, dot, dot. And then I have what I need to work the rest of the problem. Is it a Bobo, Botan, or Betsy? Okay, Betsy is correct. That means I'm dividing those front numbers. 6 divided by 15, what can those both reduce with? 3. So 6 divided by 3 is going to turn that into a 2. 15 divided by 3 will turn it into a 5. Okay. 3 more left. Take a look at number 9. What is my leading power on top? Is it a 2x? 2x what? Squared, because there's another x behind that aren't multiplied out. Notice I'm not going to multiply the whole thing. Okay, just that first term. So 2x squared, dot, dot, dot. I'm not going to finish multiplying. On the bottom, I have a 3 times an x. What's that? And then times 1 more x. 3x squared. And notice I'm not going to FOIL that out. I really just need to know that first biggest power. So that was the 3 times the x times the other x. And then is that Bobo, Botan, or Betsy? Betsy means I'm dividing the numbers in the front. And can 2 over 3 reduce? No, then just leave it. Okay. 2 more left. Take a look at number 10. What would my highest power term be on top?
You would.
2x cubed. And on the bottom, what would the highest power be? 6x squared. Dot, 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 dot. Okay, nobody cares about the whole rest of it. You just need that biggest term. Okay, bigger on top or bigger on bottom? That makes it a bottom. And the N stands for no horizontal asymptote. Vertical. Okay, number 11, last one of those, 4x squared and 2x. What's my leading power on top? Multiply. Uh-huh. And then on bottom, 2x and 3x multiplied to 6x squared. And then I'm looking at those powers. Where is it bigger, top or bottom? Top, that makes it a bottom, which means that it is also no asymptote. Make sense? All right, turn the page. So the last thing I'm going to have you do today is write equations if you know the features. So look at the top of your
features at the end of A lunch, starting of B lunch. You have B lunch, start heading to the lunches.
okay. Into the lunches. Okay, look right here. Do you remember that we found holes last time? And they were always the factors that canceled out, yeah? So what that means is that if it cancels out, it's gonna have to be in both the top and the bottom, otherwise it couldn't cross out. The second thing we learned how to find last class were vertical asymptotes. And they were left over in the denominator. That means it's gonna be a bottom only. We also learned how to find zeros. Remember that a 0 and an x-intercept are the same thing. Do we remember where those were left over? On the top, very good. Notice it says in your notes in the, I spelled it wrong, numerator. But those are only on the top. And now we have one more thing we just learned, horizontal asymptotes. Those are your Bobo, Bob, and Betsy. Okay? So for number 11, put y equals, and then give me a big long fraction. Okay, and we're gonna take the features that we want this graph to have, and we're gonna work our way backwards. If there should be a hole at 3, where would I find that factor? Top, bottom, or both? Both, because holes cancel out. What would the parentheses have had to say? X minus 3, very good. So put in x minus 3 here, and in x minus 3 here. The next thing I want are roots at -7. That's the same as an x-intercept. Where do I find x-intercepts in the equation? Top, bottom, or both? Okay, they should be on the top. So if it's x equals -7, what should the parentheses say? X plus 7. Now, a multiplicity of 2 means that it's a double root. Do you remember how you show that? Yes, put a little square on it. Okay, so I'm going to put here multiplicity of 2 means that it's a double root. Okay. Vertical asymptotes, where do those go? Top, bottom, or both? Okay, vertical asymptotes are found in the bottom. If I want one at -4, what would that parentheses have said? X plus 4. If I want one at 2, what would that have said? X minus 2. And if I want one at +6, I'd make it X minus 6. Okay, the last thing that you have to check is the asymptote. If my asymptote is supposed to be 0, should it have been a Bobo, a Botan, or a Betsy? If I want 0 to be the answer, should this be a Bobo, a Botan, or a Betsy? Has to be a Bobo. Then all I want you to do is make sure there's more X's where on the bottom. So let's count how many on top. 1, 2, and then technically 3, because it was a double, right? So that's X cubed. How many on bottom? 4. Is it bigger on bottom? Then you did it, you're done. That's your answer. Okay. One more left like that. Take a look at number 12. Y equals big fraction. For there to be a whole at +1, what should the parentheses say? And where should it be? Both. So x minus 1, x minus 1. For my roots or x-intercepts, I want one at 0 and one at -8. Where do you put the x if you want the answer to be 0? On the outside. Very good. X on outside. And where am I going to put it? Top or bottom if it's an x-intercept? Top. So put an x on the outside. I also want to have one at x equals -8. So what would the other parentheses be on top? X plus 8. Vertical asymptotes go where? Top, bottom, or both? Bottom, I want one at 9 and one at 6. Then I do x minus 9 and x minus 6. Okay, last thing is my horizontal asymptote. I want it to come out to be 4. Should it be a Bobo, a Botan, or a Betsy? Has to be a Betsy, because if it's a Bobo, it would have to be 0. And if it was a Botan, it'd have to not have 1, right? So go ahead and write Betsy. Then that means that my powers, top and bottom, should come out equal, do they? Yes, because how many X's across the top? 3, how many on bottom? 3. Then I need to pick numbers to go in the front that will divide to give me 4. Now, there are a bunch of numbers you can pick, but give me a pair. What will divide to 4? 8 divided by 2. Perfect. Now, what if you had put 40 divided by 10? Does that still divide to 4? Then your answer would still be correct. Okay? Make sense? All right, your practice, your homework on Delta Math is 8 questions. Okay, and you have the rest of the class to do it. I'm happy to help you if you need help, and I feel like probably y'all can do it. So let me know if you need any help. No, I'm just such a headache.
That was kind of, he was like, you're like, swap them out. You're the lead.
That's wrong.
That's what you got some big. I just so. You might swallow.
Folder should be in left, and we should be out. So then how do we get mine up? For the one that like only.
But that can happen. That'll be crossed out.
There's not a 1,844. 8,000. That was so good.
Val, did you take that pass right there, honey?
You know, we can say like, inside.
Yeah, I know. I'm